10. So I'm just going to do this one more example problem. It's very similar to the one we just did. The only difference is we're now testing a claim about a population mean. So instead of making claims about mu, we're making claims about p, we're going to make claims about mu, population means. And when we get to step 3, of course the test statistic in step 3 of the flow chart for these types of problems will look slightly different than the test statistic formula for step 3 in the last example we did about population percentages. But other than that, it's almost the exact same 6-step process. It's just here we're going to test a claim about a population mean. So this one's going to be like problem 10 from the practice test. Like problem 10 from practice. And there's several more in homework assignment 8 like this. And that solution key, like I said, is online. So it's like problem 10 from practice test. You're getting one of each type on the practice test, and you'll get one of each type in problems 9 and 10 on the actual test. Here we're going to use the flow chart on pages 520 and 521 from the cheat sheet. So you get another flow chart on your cheat sheet for this type of test. It's a 6-step process, and like I said, the only real difference is going to be in step 3. So get out pages 521, 520, 521. It's right after the flow chart on 545 and 546. It's in your cheat sheet for test 3. Right before you get to table 5 in the cheat sheet, you get page 520 and page 521, which is the 6-step flow chart for doing a hypothesis test, testing a claim about a population mean. So that's the one. So that's going to be the flow chart you're going to use for problem 10 on test 3 as well. All right. So let's go ahead and get our flow chart, and let's go ahead and read the problem. First thing, remember, we're going to do in step 1, if you look on page 520, is you have to write down the claim in symbolic language. Only in symbolic language, the claim now in symbolic language is about a mean, not a proportion. So when we translate the verbal information about the claim into symbolic language, it's going to be of the form mu, which is population mean. So instead of p, we have mu here, but we have inequality sign. And of course, it'll either be a less than symbol or a greater than symbol here. And then mu naught. Mu naught is the number, it'll be the last number in symbolic language for our claim and counterclaim. So instead of p inequality sign p naught, we're now going to get something that looks like mu inequality sign mu naught. So let's read the problem and see if we can write the claim in symbolic language. So looking at example problem 2 from the part 1, this is on page 2 of that handout. Just reading along, it says, suppose that a certain reputable health organization makes the claim that the mean body temperature of all healthy adult humans is greater than 98.2 degrees Fahrenheit. So this reputable health organization is making a claim that the mean body temperature of all healthy human adults is greater than 98.2 degrees. So that means the population mean here, which is mean body temperature of all adult humans, is what? Less than or greater than? Well, they didn't use fewer than or less than. They said greater than. If you say larger than, greater than, any of those words that indicate larger or greater than, you use a greater than symbol. We're claiming the mean body temperature is greater than, and then mu naught is 98.2 degrees. So our mu naught here is 98.2 degrees, and our statement for the claim in symbolic language is mu greater than 98.2. So it's a statement about population mean, not population proportion. But it looks very similar to what you wrote down in the claim for the last problem. It's just you're using mu here instead of p. So what does that mean the counterclaim is going to be? Well, just like before, the counterclaim is the other possibility. What if the claim is false? Well, if mu, the mean body temperature, is not greater than 98.2, what's the only other possibility? That would say that the mean body temperature had to be less than or equal to 98.2. Remember, it's the counterclaim that should have the equal sign for these problems. Now, in general, like I said, in other books, the claim might have the equal sign and the counterclaim might not. But for our problems, the claim never has an equal sign and the counterclaim always does, and this is like our baseline claim. This is our baseline counterclaim. Now, we have to write this in terms of the null hypothesis and the alternative hypothesis, just like we did in the last problem. So if we write it in terms of the null and alternative hypothesis, and I hope this comes out in the video, the claim becomes the alternative, and the counterclaim, which has the equal sign, turns into the null. So the null hypothesis, H naught, which comes from the counterclaim, we replace, just like we did before, the inequality sign with the equal sign just gets replaced by an equal sign. So when we turn the counterclaim into the null hypothesis, we write it as mu equals 98.2 degrees. Comes from counterclaim. And that means that our alternative hypothesis, which comes from the claim, is written just like before, just as it's stated. So just like we did in the previous problem, the counterclaim, the inequality, turns into an equal sign and becomes the null, and the claim is just written the same way in symbolic language as H1, the alternative hypothesis. And that's the claim. So mu greater than 98.2, and our mu naught now is the 98.2. The little circle is just a symbol for degrees Fahrenheit. So mu equals 98.2 is the null, comes from the counterclaim. Mu greater than 98.2 is H1. Now I have to decide, the final thing is to decide whether or not this is a left-tailed test or a right-tailed test. Well, notice the inequality sign for H1 is a greater than sign this time. Last time the inequality sign for H1 was a less than sign, so it was left-tailed. If you look at page 520, when the inequality sign for H1 is a greater than sign, it's a right-tailed test. So this is a right-tailed test. So it's good. We're getting an example of a right-tailed test and a left-tailed test in this video. Now, it could be that on the test, maybe the one about the test for population percentages will be right-tailed and the other one will be left-tailed. I don't know. But in this particular case, this was the test that was right-tailed. Doesn't always have to be. I mean, any test could be left or right-tailed. It just depends on the inequality sign in H1. So in this case, we're right-tailed. The last problem, we just happen to be left-tailed. But we'll need to know that when we get the p-value in step 4. Now we go on to step 2. Step 2 is just like the step 2 in the last one. They give you a significance level. If you look at this, it says, if you read further enough down, it says, to determine whether or not there's, it says, now test your claim with these statistics that are given in that problem, and it says that the significance level given for this problem, near the bottom, says alpha's 0.05. Remember, the significance level is always given. The flow chart says pick a significance level that will minimize the likelihood of a type 1 error. Or the seriousness of a type 1 error. But the significance level in all the problems in this book, and in every book I've ever seen, they always give you the significance level in the problem. You just need to copy down the given significance level, and here it's alpha equals 0.05. So I'll need to remember that for step 5. Now I go on to step 3. This is the part that's a little different from the last test. This is where you get your test statistic from the given sample statistics in the problem. To test this claim that the mean body temperature of all adults is greater than 98.2, we don't do a census. We only get a sample of all adult humans. We couldn't possibly get the body temperature of all adult humans and do a census. So we're going to get a sample, and from that sample we're going to get a sample mean from the sample. And we're going to use the sample mean, and the sample standard deviation to test this claim. So it's an inferential study, just like when you do confidence intervals. So, but because we're testing a claim about population means and not population percentages, we're going to get a slightly different formula for the test statistic. We still call it Z0. It's still going to be treated like a Z-score. But if you look at the given test statistic that's given in step 3 on page 520 or 521, it says here the Z it's going to be x bar minus mu naught divided by sigma over the square root of n. That's how it's written in the flow chart. Now, this is a little bit complicated. Now, if you look at the way I solve them in all of my solution keys, the solutions here, the solution key to the practice test, the solution key to homework assignment 8, I always convert this into a simpler form when I use it. Because I remember that anytime you have a complex fraction where you divide one fraction by another fraction, you can always make it simpler if you just flip the bottom fraction and multiply. So this is equivalent to saying z naught is equal to x bar minus mu, make sure it's in parentheses, times, you can multiply by what's called the reciprocal of the denominator. So if you flip the bottom fraction and multiply, you get the same basic formula, only it's a little easier to plug into the calculator. You can put x bar minus mu naught in parentheses, the numerator, and then go times square root of n, and then you could put all of that